So I had started class by saying this unit is going to be using 3 of our non-contact forces. We're just going to be kind of looking at it in terms of potential energy. So gravitational potential energy, magnetic potential energy, and electrical potential energy. So all the things that you already know about those non-contact forces are going to relate in this unit, but we're going to be looking at potential energy. So first of all, we kind of need to see what the heck is energy, and specifically, what's potential energy all about? Okay, so energy itself is the ability to cause motion or to create change. That's very vague, very generic definition. That's kind of what energy is. There are so many different forms. You can have like light energy, sound energy. You can have energy of, like forces, like if you're pushing or pulling, right? Those cause change. So many things fit under this category, okay? Yeah, we'll leave it at that. So lucky for us, energy can actually be transferred, and it can be kind of like exchanged. Like, so it can go from one form to another to another. So if you're talking like mechanical energy in a generator, that can be transferred into electrical energy that we can use to power our devices, to power all of our electronic equipment, things like that, right? You can also use electrical energy to go into mechanical energy. So like if I have a blender, I plug the blender into electricity, like into that electric socket, the electricity will turn the blades on the blender, which is mechanical energy. So you can go from one form to another or one back to the other, like lots of transfers can happen. And we're actually gonna look at a lab where we go like through 3 or 4 different transfers, just from dropping different bouncy balls. So we'll take a look at that. But there's 2 main categories. Are you doing your notes there, Marcus? Okay, I just didn't see him. Perfect. 2 main types, kinetic and potential. This year, we're going to focus mostly on potential energy. Next year, we're going to have a whole lot with kinetic, right? So it's not like kinetic's not important. It just isn't in our standards for this year. We'll focus on the potential, deal with the kinetic next year, mostly. Anyway. But it is important to realize that kinetic energy is the energy of movement, or moving energy. So anytime you see something moving, it has kinetic energy. Okay. Potential energy is energy that is stored up, or energy that something has because of its position. And you're like, well, what does that mean? Well, stored up like in gasoline. That's a type of chemical potential energy. That gasoline has potential energy, and it's built up in those bonds of the gasoline or the diesel fuel or the kerosene or whatever. When that fuel gets burnt, that energy gets released. And so it's storing that energy up, kind of like a battery. If a battery is fully charged, it's storing that energy waiting to be used. Food is a type of energy that is stored. The energy in the food is there. Once we consume it, our body starts to digest it and break those chemical bonds in the food. That releases the energy that our cells can then use to power our body, right? So there's a couple different kinds of stored energy. There's also a few that deal with position. So I raised this above my frame of reference. I've changed its height. It has more potential to fall when it's up here than it does when it's at the frame of reference. More potential to fall here than it does when it's already down on our frame of reference. Okay, so the positioning, if I would raise it even higher, it has even more potential to fall. Basically, it's giving gravity more of an opportunity to act on it. David was kind of showing this with his binder. Let me get mine. Oh, not that one. Sorry. If I change this rubber band's position, right? So here's how it normally is. It's just, flopping around. If I change its position, right? Kelsey's like, please no, I'll be good, right? If I accidentally shoot you, I'm sorry, I don't mean to. Like, it might break, might get away from me. You just don't know. I've changed its position. You guys seem a little nervous. You don't seem so nervous when I'm just like, ooh, ooh, right? But as soon as I change its position, you guys are all kind of squinting at me like, oh gosh, getting a little twitchy. Right?
Like, sorry.
Anna, way back there. All right, I've changed its position, so now it has more potential energy to return to its original position. All right, so there's a couple that are dealing with changing position, and there's a couple energies that are stored up as potential energy. And so we'll take a look at both of those. So you can see this example. It's showing she's raised this above the reference point of the ground, of the frame of reference. And so this ball has potential energy because of its location or position. When it's on the ground, it's not such a big deal, right? And so we'll see a couple examples of that in our videos in a minute. Okay, potential energy a lot of time is going to be abbreviated capital P, capital E. I'm lazy. I'm okay with you guys being lazy too, as long as you understand that those abbreviations, what they stand for. Yes?
Isn't that physical education?
Can also be physical education, but we're saying it's potential energy. Okay, so gravitational potential energy is dealing with what, do you think? What do you see in that word gravitational, Marcus? Gravity. So guess what? If you give gravity more of an opportunity to work on something, you are giving it gravitational potential energy. Here, there's not a, if this is my frame of reference, there's not a whole lot of potential for this book to change vertically, right? It's already at the lowest point. But if I give it some height, I've given it opportunity for gravity to pull it downward, which it does. All right, so we're also going to be dealing with looking at elastic potential. So anything that has elasticity, rubber bands, right? We'll look at some other, I don't want to give you too many examples because we're going to get into the specifics of all these. Chemical. We mentioned this with fuel, with food, with batteries. All of those store up energy and they have the potential to cause change. They're not doing it right now, but they have the potential to do it if something happens. So if I burn that gasoline, or if I eat that food and my stomach starts to digest it, or if I turn that device on and it starts using the battery, right? So that energy is stored, just waiting for something to use it. Electrical potential energy. Well, we already talked a lot about electrical forces, and so we're going to apply these to potential energy as well. And then, what do you think magnetic potential energy is going to be dealing with? You're such a genius, right? And those are the 5 that we're going to focus on. Those aren't the only 5, but those are the 5 main ones that the state of Ohio says that we need to talk about, so we're going to leave it at that. All right, so we're going to start with gravitational potential energy. Obviously, always think gravity. You guys had a lot of experience with gravity from our non-contact forces unit, so all those things are still true. But this is a type of potential energy an object can have because of its vertical position. It makes sense, right? Gravity's pulling downward, so it's going to be a vertical force. All right, and so we're still dealing with the frame of reference, so it's our perspective, our point of view in relation to that object or that description or that situation. Here's something really important. 2 variables are going to affect how this potential energy works. So you might want to put a star by slide number 4, like by these 2 variables. These 2 variables are very important. The height above the reference point and the mass of the object. So you might want to put a star by that height and mass. Those are the 2 things that are really important. That's what's going to affect the GPE that something has, the gravitational potential energy. So how high it is above the reference point. So if it's on this first tread, it has a little bit, now it's got more, now it's got more, now it has the most. Okay? It's the highest. So if you change either of those 2 variables, you're going to get a change in the gravitational potential energy. Those are the 2 things that affect it, so changing them will have an effect on your total potential energy. and again, you might wanna put a star or somehow kind of mark this, if you didn't, already do that. Okay? Okay. So, this isn't just my abbreviation, this is kind of a universal abbreviation. GPE, because gravitational, potential energy is kind of a mouthful. So, again, kind of on the lazy side, it's easier just to be like, hey, let's call this GPE, right? So anytime you say GPE, we're talking gravitational potential energy. Okay, so the first thing you need to do is identify, like if you're dealing with GPE, what's the frame of reference? What's that reference point? Where is like ground zero? Because in my examples, I've been using this tabletop as our frame of reference, but really, I mean, there's the floor. So if I didn't say my frame of reference, you wouldn't know, am I talking about the table or am I talking about the floor, right? So you need to be specific, like what's our ground zero? Doesn't always have to be the ground, but like what's our bottom positioning in this situation? So obviously the ground is for this elephant and the ground is for this example. A lot of times it is, but like if you're talking about a roller coaster, it might be the absolute lowest point of the coaster, not the ground that the track is sitting on. So you would need to know that, or you would need to have that information given to you before you would kind of do calculations or something. Okay, so let's take a look at this. This is the basketball. The basketball is not changing, right? So mass is not going to be affected in this example. But what is changing? What do you see changing from location A, B, C, and D?
The height.
Yeah, the height. So because it's the same object, the mass isn't changing, but the height is. So the higher an object, the more gravitational potential energy it has, because you're giving gravity more of an opportunity to pull it down. So where is it going to have the most GPE? Which position? What do you think, Ava? Let me ask this. Where is it the highest?
B.
That's your answer, right? The highest is always your most GPE, right? And so it's saying C is our reference point, and then D is like kind of going back up. So if you have the least to most, you go C, D, A, and then B, okay? But for the frame of reference, most cases it'll be the ground. Most. All right, so let's take a look at this example. We have the girl is at the highest, right? And she has more GPE because she's farther from the reference point, which is the ground. We don't know their masses, but they look like they're pretty close. Because her height is so much greater than the boys, we can assume that that would have more of an effect on the GPE than the masses. The masses could be a little off, but we can't tell that exactly. Because the girl has more height, she has more GPE. She has more ability for gravity to act on her. The boy has less because he's closer to the ground, meaning he has less opportunity for gravity to act on him. This is pretty common sense, right? Like if you think about it, it makes sense. I love it when science matches with logic. It's friendly that way. Okay. So now let's look at this. Oh, sorry. He has less height. She had more, so more GPE. He has less height, so less GPE. And next year, we'll actually calculate these. There's a formula for GPE. It's mass times gravity times height. So gravity is a constant, but the mass and the height can change. And so we'll actually calculate those next year. Okay, so let's take a look at this. I see object A has 50 kilograms of mass, object B is 25, and object C is 50. So the yellow ones are 50 kilograms, the blue one is 25. So this says which objects has the greatest GPE. So if I look at this, I see that the ball B and the ball C are the same height. How would I distinguish between which one of those would have the most GPE?
The size of them.
Very good, the mass, right? So it says C is 50 kilograms, more mass, more GPE, just like with more height. Now, that's how you tell the difference between these two, because they have the same mass, but different heights. So you could look at both variables kind of independently. First look at height, well, these two are the highest, and then look at mass. This one wins. Next, if you look at mass, well, those are the same, but the height's different. So this one still wins, okay? So C has the most GPE. Why? Because it has the greatest height and mass. So if the mass is different, then obviously it's going to go to the most massive object. That one wins. And I'm not going to give you ones where they have different masses and different heights. Like, that gets a little too confusing. So it'll be examples kind of like this, where you can kind of easily tell which one would be greatest.
Wouldn't both of them know they ran at the same time?
No. Hold that thought. We're going to actually do a lab that's similar to this. Okay, so hold that thought. Okay, let's go ahead and let's end with a song. This is really, it reminds me a ton of that Friction song, kind of like that old time. It'll stick in your head too.
Science, not water.
You guys do